So, factor and solve, factor and solve. There's another way to solve this. It's called trial and error. Pick a value of x, plug it in, evaluate, and see if it equals 0. You want to try that? Let's try it. Let's try 1. You think 1 is going to work? Let's try it. What do you get when you plug a 1 in? 1 squared is 1, plus 5 times 1 is 6. So 6 plus 6, is that 0? No, that's 12. It doubled instead of canceled. Wow. So trial and error is not a very, very efficient way. So the way that we learn to do it, hopefully in Algebra 1, is when you have something like this, like a quadratic, you factor it. There's something called the zero product property. Here's what the zero product property says. If A times B equals 0, it's because A equals 0 or because B equals 0 or both. That only works with 0, right? It doesn't work with 1. If you have two numbers multiplied together giving you 1, neither one of them have to be a 1. For instance, 5 and 1/5. But if you have two numbers multiplied together equaling 0, at least one of them has to be 0. That's the zero product property. So I can factor this. This is going to be a double bubble. Okay? And then how do we factor it? Well, the first one is x squared, so that has to be an x, and that has to be an x. What we're doing here is we're unfoiling it. Do you remember how to unfoil? No, well, I'm going to teach you, okay? This 6 is your last. In FOIL, it's the L in last. So the product of these two have to equal 6. So what are some possibilities that multiply together to give you 6? 3 and 2. Let's see if that works. It's kind of a guess and check. When you do the inner, which is the I in FOIL, and you do the outer, which is the O in FOIL, the sum of I plus O has to equal, in this case, it has to equal 5x. It has to equal that middle term. Okay, it has to equal the middle term. So if I put a plus here and a plus there, let's see. What would be the inner product? 3 times x is 3x. And what's the outer product? 2 times x is 2x. What's 2x plus 3x? 5x. Did it work? It worked. Yeah, it actually worked. Now, that is the correct factorization. But let's see if another possibility could have worked. Could I have chosen a 6 and a 1? Let's see why it doesn't work. Yeah, I could have, right? Because what's 6 times 1? 6. So I got the last part right. But let's see if the inner and outer give us 5. 6 times x is 6x. What's 1 times x? 1x. I'm adding them, not subtracting them, correct? So 6x plus 1x would be 7x, which is not 5x. So that would be, that wouldn't work, okay? So factoring is sometimes a little bit of trial and error. So in this case, we got x plus 3, and we got x plus 2, and just don't mind the ice falling. Anytime you hear the ice fall in here, just condition yourself to think, I got to do my math homework, right? Anytime you hear the ice fall, you're like, I got to do my math homework. Okay. Now, once you have them equal to 0, because it's factored, now you can say x plus 3 equals 0, or x plus 2 equals 0. Okay? And now we can solve these linear equations. I subtract 3 and I get x equals negative 3, or I subtract 2 and I get x equals negative 2. And because it's a quadratic, it had two solutions, and I found both of them. Okay? So there's no more guessing and checking. I'm finding it by an algorithm. We call this an algorithm. It's just a process or a method for obtaining the right answer. Okay. Factoring. How does that feel? You remember doing that? Yeah. Okay. You're unfoiling it. So if you know how foiling works, you can unfoil it. Now, it's not going to be as nice as unfoiling a breakfast taco, right? That's a really happy experience, isn't it? You unfoil a breakfast taco and you're like, there's a breakfast taco in there. I get to eat it. This is almost as delicious. Okay. Let's go to the notes. We're going to do 1.1. It's not a misprint. Under your Chapter 5 module, the first thing there before 5.1 should be 1.1. The reason we're backtracking to 1.1 is because 1.1 is the basics for Chapter 5. Evaluating, simplifying, and whatting. What does it say there? Simplifying, evaluating, and factoring. Yeah, factoring polynomials. So we're going to go back to the basics here. Okay, you ready? We skipped Chapter 1. Okay, but we're going to go back and do 1.1. It's that important. A term. We just talked about this today in pre-cal. A term is a number, a variable, or a combination of symbols and letters and numbers that are separated by a plus or minus sign. That's super important. Terms are separated by plus or minus signs. So here's an example. If you have 1/2 x, turn these commas into plus signs. Turn these commas into plus signs if you want. That would be how many terms in that expression? 1, 2, 3. We have 4 terms, right? 4 terms. You got the first one, the second one, the third one, and the fourth one. They're separated by plus or minus signs. By the way, I don't think this has it up here, but this is what's called a mathematical expression. A mathematical expression. An expression is just a collection of terms and factors. Okay, so that's what a term is. A term is separated by what? Plus or minus signs. Let's insert another one here. There's another one that should be here in here that's not. A factor. A factor is also a collection of variables and numbers and symbols, but it's separated by, guess what? Not plus or minus signs, but separated by multiplication or division. Yeah, multiplication or division. If you go back to it, y'all stay here, but I'm going to go back to the warm-up real quickly. In the warm-up, how many terms did my polynomial have originally on the left side? 3 terms. Good. And I factor those 3 terms into how many factors? 2 factors. Okay? The factors were separated by these parentheses. Okay? So that's the difference between terms and factors. Terms are separated by plus or minus signs, and factors are separated by multiplication signs. Now, each of those factors had 2 terms. Would you agree? The first factor had 2 terms. The second factor had 2 terms. Okay? So now we know the difference between terms and factors. Okay, back to the notes. A coefficient is just the number in front of the variable. Let's just get to the end of here. We won't read the first part. It's just the number in front of the variable. The number in front of the variable. So what would be the coefficient of 1/2 x? 1/2. What would be the coefficient of 5yz squared? Just a 5. What's the coefficient of negative 2ab? Negative 2. And what's the coefficient of 1? Because there's an implied 1 in front of it. Yeah, I wrote it with a highlighter. 1. There we go. Okay, so a coefficient is the number in front of a term. A constant term. A constant term is basically just a number. There's no variable there. There's no variable. Okay? Here are some examples of constants. 4, 100, -5, and 2/3. They can be big, they can be small, they can be positive, they can be negative, they can be fractions. Okay? Now, they really do have an x. If you want to think about them as having an x, they do have an x, but it's x to the 0. Okay? And what is x to the 0 actually equal to? 1. And so the 2/3 times x to the 0 is really the same as 2/3 times 1, which is really 2/3. So that's why we say they're constants. They don't have a visible variable. It's because the variables are there and they're all to the 0 power. Right? Like terms are terms that have the same variables raised to the same exponents. So 3x squared and -5x squared. 3x squared and -5x squared. So if I put 3x squared minus 5x squared, how many terms would that have? It would be 2 terms. As it's written, it's 2 terms, yes? The 3x squared is the first term, and the -5x squared is the second term. Because we can write that as plus minus 5x squared. So the second term is minus 5x squared. How many factors does the first term have? It has 2 types, right? The 3 and the x squared. The second term has how many factors? 2. The -5 and the x squared. Got it. Now, why are like terms important? Because we can actually combine like terms. What would 3 of those minus 5 of those be? -2 of those. And those are x squareds. Yeah. You can combine like terms. 3 of those minus 5 of those makes -2 of those. Those being x squared. All right. What if I had 7? Let's write it down here. 7a to the 4th b cubed minus a to the 4th b cubed. How many terms does that have? Should be 2 terms, right? How many factors does the first term have? 4. We have the 7. We have the a to the 4th. and we have the b cubed. So it should have 3 factors. Okay. Now, are those like terms? Yes. So what is 7 of those minus, what's the implied number in front of the a? A 1. What's 7 of those minus 1 of those? 6 of those, and those happen to be a to the 4th b cubed. I always say the word those. I use that pronoun there because it doesn't matter what it is as long as it's the same. 7 of those minus 1 of those leaves you with 6 of those. Those happen to be here, a to the 4th b cubed, right? What would 7x squared y minus 3x squared be? Are those like terms? No. Those are not like terms. These are not like terms. So can we combine that and say that it's 4x squared y? No. It's just 7x squared y minus 3x squared. It's like 7 apples minus 3 oranges is what? We're not putting them in a blender, by the way. It's just 7 apples minus 3 oranges. That's all it is. We can't combine unless they're apples to apples. That was a fun game growing up. And oranges to oranges. I never played that. Okay. Combining like terms. We already talked about that. The distributive property. Distributive property is really just multiplication. Distributive property is really just multiplication. If you see something like 3 times the quantity 2x minus 5, that's an implied multiplier right there, right? And to get rid of the parentheses, all you have to do is distribute, which means you multiply it through. I call this the sledgehammer method. Right? When you hit something with a sledgehammer, you expand it. You destroy it really if you hit it hard enough. But you're making it into smaller pieces. You're breaking it down. Okay? So you hit this with the little sledgehammer, dink, and the parentheses go away, and you're left with 6x minus 15. Okay, that's the distributive property. FOIL is really a mnemonic for a quick distributive property. Because here's what the distributive property would look like. Watch this. I would take the x minus 4 and I would distribute it through. So that gives you x minus 4 times 2x plus x minus 4 times 1. Okay, that would be if I distributed the x minus 4 to both terms. And then I'd have to redistribute by distributing the 2x and by distributing the 1. We don't think of that in the terms. We don't really expand it that way, although we could. Y'all learned a mnemonic device like we learned in the warm-up here, or we reviewed in the warm-up. FOIL, first, outer, inner, last. First, outer, inner, last. So you can expand it in one fell swoop, but you will have to combine the middle terms. You combine the like terms in the middle. Okay? And that's a very important step because as we talked about in the warm-up, when you're unfoiling it, you have to check to see if the outer and inner add up to give you the middle term. Okay? It's kind of a trial and error thing. The combination of the inner and outer have to equal the middle term. Okay. Now, what does it mean to evaluate an expression? Evaluating an expression means that you're plugging in numbers into variables. That's it. To get a numeric expression. You're plugging in numbers into variables. Let's go ahead and finish that. To get a number. That's what it means to evaluate. So if you see something like 5x minus y squared, and you're supposed to evaluate it for x equals 4 and y equals negative 3, guess what we're going to do? Are we going to FOIL? If it says to evaluate, is there anything to FOIL here? No. It basically says, hey, plug in a 4 for x and plug in a negative 3 for y. So here's what it would look like. 5 parentheses minus parentheses squared. I always do that first. I take all my variables and I turn them into open receptacles that now have a place for me to put whatever I want in there. What am I plugging into the first parentheses? Well, that was the x. What is x? 4. And into the second parentheses, when there was a y, I'm plugging in a negative 3. Now notice having the parentheses in place first really helps you, especially on that last one, because your negatives can get discombobulated if you're not careful. All right? Now we just evaluate it using your dear Aunt Sally's. What's 5 times her rules, I should say, PEMDAS. 5 times 4 is 20. Now over here, it's still going to be minus. I don't multiply the negatives together yet. I don't do that. No, no. I have to exponent first, right? PEMDAS. Inside the parentheses, I have a negative 3. Now I have an exponent. What's negative 3 squared? 9. Ooh, I wrote it with the highlighter. That was close. 9. But the minus out front is still there. Yes, yes? Yes, yes. Now what's 20 minus 9? 11. I guarantee you could put this on Twitter or X or whatever you want to call it and say evaluate, and you'll get people that evaluate it wrong, and they'll be arguing with each other over who's right. Because some people will do the negative first and say it's 20 plus 9, and y'all know to do it's 20 minus 9, and you get 11. So the people that say 29, you can say they're wrong. And that's why that meme on the left side of the projection board is funny, right? We did that on the first day of the school this year, right? We did the problem that broke the internet. Bless you. Okay, bless you. Again, bless you. All right. Whoa, look at this. AB minus 3b over a squared minus 4. Evaluate it when a is 1 and b is 2. Okay, my first step is replacing all the variables with parentheses. So parenthesis, parenthesis, minus 3, parenthesis, all over, parentheses squared, minus 4. It's kind of fun to do it that way. And you're guaranteeing that you're not messing up, okay? So now I'm going to plug in. An a is a 1, so everywhere there was an a, which is those two, I put a 1. And b was 2, so I put a 2 there and a 2 there. There's the setup. If you don't have it set up right, are you going to have a chance at evaluating it correctly? No, no. Now we simplify it. 1 times 2 is 2. Minus 3 times 2 is 6. 1 squared is 1 minus 4. So I've got that as my intermediate step. And now 2 minus 6, that's negative 4. Over 1 minus 4 is negative 3. And I ran out of space, so I'm going to a new column. Yum. It doesn't simplify numerically, but what's a negative divided by a negative? Positive. I would prefer, if you work straight down and you run out of room, to not even put an equal sign. We're working straight down. Just go to a new column. If you go, like if you pull a swerve right there at the end, and you say equals 4/3, you're not wrong, but it doesn't look right. Believe it or not, it doesn't look right. We would prefer a new column with the 4/3 over there. All right, everything works straight down. It's equivalent to the line above and below. We've been practicing that all year. Now with notability, of course, you do have the option of just scooting that up, and now you have room for your 4/3 down there. And that's kind of the prettier way to do it, right? But most of us didn't do that, so I'm just going to do it the way I didn't first. Yeah. If you're writing on a test or on a paper, you can't move stuff after you've written it down unless you erase it. I don't know if y'all remember that, right? Have you ever tried that when you're writing on paper? Have you ever tried like undoing something by doing an undo button or circling it and trying to move it? It doesn't work really well, does it? Okay, so that's what evaluating does. What does it mean to evaluate? We're plugging in numbers into variables to get more numbers. Yes, yes? Yes, yes. Okay. Example 2, simplify each expression. Write in standard form. Okay, I'm glad they said that. Because if you're asked to simplify something, that's kind of a wide open instruction. What does it mean in general to simplify a mathematical expression? Smaller? That means fewer things in it, right? So that could mean fewer terms, fewer factors, fewer parentheses, so on and so forth, right? So combine like term, combine like fractions, get rid of parentheses. That's what it means to simplify. Now, it says to write it in standard form. You remember what standard form is? Standard form is like this. It's like x squared plus x plus 1. It's descending order of degree. Descending order of degree. We just had that on our test. I gave you the version of a parabola that's in standard form. But you can also have like an x cubed term. You can have an x to the 4th term. That's fine, as long as it's written in descending order of degree. That's what standard form means. Okay, so they gave us a target at least. Simplify each expression. Make sure your final answer is in standard form. Okay, so we have 2 big terms, right? I have 1 big term minus another big term. Inside the first term, set off by the parentheses, I have 3 more terms, yes? Inside the second term, set off with parentheses, I have 3 terms. If simplifying means having fewer parentheses, let's go ahead and tear down the parentheses, all right? Is there anything to distribute in the first one? No. I have a 1 on the left implied, which we don't distribute, and I have a 1 on the right side, which implies to distribute a 1. I don't have to distribute a 1, right? So the first one, the parentheses were there just for grouping purposes. I don't really need to distribute anything. But on the second one, I have a -1 implied in front. Yes, yes? And what's it called if I multiply it all the way through? Rhymes with D and rhymes with distribute? Distribute. Yeah, or distribute. Yeah. Let's distribute this. -5x² -2x³ +3. We distribute that negative all the way through. Okay, now that I've gotten rid of the parentheses, I can look to combine like terms, right? Do we have any like terms? Let's start with the largest degree. What's the largest power of x you see in here? 3. I have a 3x³ term there and an x³ term there. We call those cubic terms. What is 5 of those minus 2 of those? 3 of those, and those are x³. All right, now let's look for x² terms. I have an x² term there and an x² term there. Notice what I did? I double underlined them to show that they're the same terms, like term. That becomes -11 of those. And then do I have any x terms? Do I have any terms that have just an x in them? No, so there's no linear terms. We call those linear terms, x to the first. But do I have constants? I do have constants. I'll triple underline those. 12 of those plus 3 of those is 15 of those. Is that written in descending order? Is that standard form? Yes. Is that simplified? Yes. That's about as simplified as we can make that. It's going to end up being 3 terms for sure. The first term has 2 factors. The second term has 2 factors. And the last term has 1 factor, 15. That's it. We simplified. All right, y'all try this one on your own. I'm going to do it quietly up here. You're going to do it quietly at your desk, and we'll just check each other's answer when we're done. I'll look at some of y'all's iPads from here, and y'all can look up on the board. What does it mean to do it in standard form if you have 2 variables? Well, you typically write the largest power, collective power of the variables. So a² could go first, and then a times b, that's not like terms, but because there's 2 variables there, it kind of carries the weight of like a². So it could go second. And then the 4a is a linear term. It's just a single variable, so it can go third. But if you wanted to do it with your a's first, 2a² minus 4a, and then the leftover guy minus 7ab, that's fine too. Okay? Did y'all get that? All right, so that was just expand and collect. Hit it with a little sledgehammer. All right, now we can do some foiling here. Now I have a 2-term factor times a 2-term factor. All right, 1 factor, 2 factors. Each factor has 2 terms. This is where we first outer inner less. First outer inner less. Okay, so let's do the first first. X times 3x. Those are the first ones in each factor. That's going to be a 3x². The outer is going to be x times 2, which is 2x. And the inner is -4 times 3x, which is -12x. Those are important later on. And then the last is -4 times 2, which is -8. Now, whenever you FOIL, you'll always have the inner and outer left to combine. So what does that combine to give you? -10x minus 8. Oh, it is 3x². Sorry, my bad. Yeah, thank you. It's easy to make errors at the end. Now, let's try this. Let's slide this up and pretend we don't see what it was to begin with. What if I asked you now to factor 3x squared minus 10x minus 8? Here's what you would do. You would be like, okay, this is going to be a double bubble thing, isn't it? It's going to be a double bubble thing. To get the 3x squared, it has to be the first, right? That times that. 3 is a prime number, isn't it? There's only one way to factor a 3. It's got to be a 3 and a 1, yes? So this would have to be a 3 and an x, and the other one would have to be an x. Does that give you a 3x squared when you multiply the first? Yeah. Let's look at the last. The last is negative 8. Now here's where you run into problems. Negative 8 can factor in several ways, yes? It can be 1 times 8 or 2 times 4. How do you know which one to use? It's called trial and error. You just try it out. Okay? You want to try the 8 and the 1? Or let's try the 8 and the 1. Now, you have choices. It can be 8 and 1 or 1 and 8. Those are two different possibilities. Let's check the inner and outer. The inner here is 8x, and the outer is 3x. What's 8x plus 3x? Is that 11, or is that 10? No. What's 8x minus 3x? Is that 10? You're either going to add those or subtract those to get the middle term. That doesn't work, does it? So it's not going to be that. Now, what if it's not the 8-1? Could it be the 1-8 combo? That would give us a 1x on the inside and a 24x on the outside. That's even worse, right? 24 plus 1 is 25. 24 minus 1 is 23. So guess what? We tried the 8 and the 1 and the 8. That doesn't work. So let's try something else. What's another way to factor 8? How about a 2 and a 4? Let's see if that works. On the inside, we get a 2x. On the outside, we get a 12x. What's 12x plus 2x? That's 14x. But what's 12x minus 2x? 10x. Okay, so how are we going to make sure that we get a negative product? The larger of those two has to be negative. In order to get a negative 10, the larger of the two has to be negative. So the 12x came from the 3x and the 4, so I'm going to make that a negative 4. And I'm going to make this a positive 2. That gives you a positive 2x and a negative 12x. Bless you. Does that give you a negative 10x on the inside? It does. And does that give you a negative 8 on your last? You can check your last now. You know what the last is going to be. You know it's going to work. 2 times negative 4 is negative 8. So those inner numbers either subtract or add to give you the number you want. So it's really guess and check. Now, is that what we got up above? Oh, uh-oh. We got a slightly different answer. Is that the same answer, though? Yes, because multiplication can be done in any order, just like addition. You know what we call that property? A times B equals B times A.
Wait, what if you put the 3x like with the negative 4? Like, what if you have to put 3x like the bigger one first?
Are you saying can it be 3x plus 4? Is that what you're asking?
No, like, does it matter if 3x goes first or like x goes first?
No, it could either way. Yeah, that's what I'm saying here. A times B is equal to B times A. This is called the commutative. You should know this. This is the commutative property of multiplication. They're both the same. A times B is the same as B times A. It's just a matter of preference. When you factor, you're probably going to put the 3x term first, just because that's the way I do it, and you're learning from me, right? It's a prime number, so you put the 3 first and the 1 second. This is just how I do it. But you do want to check the inner and the outer. Okay, so factoring is a little bit more involved when you're unfoiling, because you have to come up with the numbers where the O and the I add together to give you the middle term. But it's not that bad, is it? It's kind of fun. Everyone say kinda. Kinda. Okay, sorry. Yeah, it's kind of fun. Everyone say fun now. Fun. There you go. It's kind of fun. Not kind of fun. It's kind of fun. All right, now over here, let's look at this. Does foiling work here? FOIL does not work here. Why not? Here's 2 terms. This one's good. 2 terms, that works, but what is this guy? 3 terms. Uh-oh, that's no good. FOIL only works for 2 terms times 2 terms. FOIL is 2 terms, A plus B times C plus D. Okay? 2 terms times 2 terms. That's it. So what do we do if we can't FOIL? Well, we're going to use the D word. It rhymes with distribute. It's called what? Distribute. We're going to distribute. Okay. Now here's what it's going to look like. You're going to like this, and you can do this too when you're foiling. This is really what FOIL is. We're going to take the first term in the first factor. The first term in the first factor. That's pretty easy to spot, right? It's the first guy you come across and you walk up to it. What's up, 2x? And we are going to distribute by multiplying it through all the way to everything in the other factor. Okay, we're multiplying here. Let's go for it. What is 2x times 4x squared? 8x to the third. X times x squared is x cubed. 2 times 4 is 8. Yes, yes? All right, next term. 2x times negative 3x. That's going to give us a negative 6 for the number, and x times x is x squared. Yeah, good. And then we do the last one. 2x times positive 5. Well, 5 times 2 is 10, and then it's just x. So that's what we get when we distribute the 2x all the way through. So far, so good? Okay, I'm going to switch flavors here now. Boysenberry. Now I take the negative 1, not the 1, but the negative 1, and I distribute it all the way through to all three. Here we go. Negative 1 times 4x squared is negative 4x squared. Negative 1 times negative 3x squared is positive 3x. And then negative 1 times positive 5 is negative 5. And that's it. This method works for anything times anything. You can have 5 terms times 10 terms if you want. And you just distribute the first 5 to all 10, the second 5 to all 10, the next third one to all 10, the fourth to all 10, and finally the fifth one to all 10. Okay, you'll have 50 terms. Yucky, yucky, gross, gross. Okay, here we have 2 times 3, we have 6 terms. Now we can look to combine like terms. Let's start with the leading degree. What's the largest exponent here? X cubed. I'm going to underline it. Is there another x cubed anywhere else? No, so I'm going to write him down first, x cubed. Now I'm going to double underline all my squareds. Negative 6 of those minus 4 of those gives me negative 10 of those. And then I'm going to triple underline all my x linear terms. 10 plus 3 is 13. And I don't have to underline the last guy because he's by himself. So that's just minus 5. Oh, I forgot the x. Yeah. There we go. Thank you. Is that standard form? It's written in descending order of degree by exponents? Yeah, that's descending order. Okay. So I wouldn't ask you to factor one like that. That was a little bit more challenging. But when we factor a trinomial, which is what we're going to be doing, it's unfoiling. Okay. All right. Let's try it. We're factoring these into prime polynomials. A prime polynomial just means something of the form ax plus b. Okay, this is a linear factor. It's considered prime. Or something like ax squared plus b. This would be a quadratic prime. I don't think we're going to see quadratic primes. But if you can get it factored into a linear factor of the form ax plus b, it's going to be a prime factor. Okay? Do your math homework, right? You heard the ice fall. Factor the polynomial using GCF. Okay, I'm glad it says this because guess what the first rule of factoring is? The first rule of factoring is to look for a common factor. Pull out any common factor. Pull out the greatest common factor. If after you do that there's still more factoring to go, then you look to unfoil something. But the first rule of factoring, whether you're told to do this or not, is to what? The first rule of factoring is to what? Prime factor. Yeah. You can say GCF if you want. GCF. Okay. So how many terms do I have here? 3. I have 1, 2, 3. Let's look at the number first. Is there a factor 8, 4, and 12 that is common? They're all even numbers, so 2 is common, right? So I can factor a 2 out. But is 2 the GCF? 4 is the GCF. Yeah. So let's pull the 4 out first, okay? So I got the number. Let's look at the x's. What do they have in common? One of them has 3 of them, and the other 2 only have 1 of them. So what do they have in common? You have to take the smallest of the exponents. So x to the first, right? That's the smallest of the 3 exponents. 3, 1, and 1. You take the 1 because that's what they have in common. And what about the y's? Y to the first, y to the first, y to the second. They all have common at least what? just y to the first. You take the smallest exponent, okay, because that's what they have in common. All right, now we put a parenthesis here, and we're going to factor out. Now, factoring out is the same as dividing out. Keep that in mind. Factoring out, I'm going to write that. Factor out equals divide out. That's what we're doing. We're unfoiling here. It's like dividing. So what would be left if we factor out a 4xy from an 8x cubed y? A 2, because 8 divided by 4 is 2. What's x cubed divided by x? X squared. And what's y divided by y? No. Y divided by y is, what's anything divided by itself? How about that? 1. Yeah. So really what we did off to the side here, we did 8x cubed y divided by 4xy. This divides out to give you 2. This divides out with this to leave 2. And these divide out to give you 1. So we're left with 2x squared times 1, which is 2x squared. Okay? What do we get when we factor a 4xy out of itself, 4xy? We're left with a negative 1. Very good. Negative 1. And what are we left with when we factor a 4xy out of 12xy squared? Let's do this one at a time. What's 12 divided by 4? 3. What's x divided by x? 1. So we don't have to write that down. And what's y squared divided by y? Y. So it's what you start with divided by what you factored out. Now, can we do anything on the inside? Do we have any like terms? 2x squared minus 1 plus 3y, or any of those like terms? No, they're not. So guess what? We're done. Yeah. This was just an exercise in factoring. Okay. Factor the polynomial by grouping. I'm glad it said how to do it. How many terms do we have here? 4 terms. Okay. When you have 4 terms, you are not going to unfoil it. We only unfoil 3 terms like we did in the warm-up. Riley, are you okay today? Too much Taylor Swift over the weekend? Yeah. Yeah, it was like 3 hours long. But it went by fast. Well, the Evermore part was kind of slow. Folklore was okay. 2 of my favorite songs are from Folklore. 2 of my favorite songs. I like. My favorite song is the one that she gave to that other band, which is the Better Man. Better Man. That's my favorite one. But then I like Illicit Affairs and August. I like August as well. Yeah. Let's see here. Factor by grouping. You're going to have 4 terms. So here's what you do. You group the first 2 together, and then you group the second 2 together, and you put a plus sign in between them. Okay? You put the first 2 together, and the second 2 together, and then you put a plus sign in between them. Now what you're going to do is you're going to pull out GCFs from each. Pull out GCFs from each. So if you look at the first one, 4x cubed and minus 3x squared, what's common in either of those? Do they have a common number that we could factor out? No, but they do have how many x's in common? They have at least one. They have 2 in common, don't they? You take the smaller of the 2, 3 and 2. So if I factor that out, what am I left with? What's 4x cubed divided by x squared? 4x. 4x to the first, right? And then minus 3, because x squared divided by x squared is 1. So I'm left with 4x minus 3. Let's switch flavors here now. On the next one, 8x minus 6. Do they have any numbers in common? 2. Do they have any x's in common? No. Okay, so I'm just going to factor out the 2, and now I factor out. What's 8x divided by 2? 4x. Minus, what's 6 divided by 2? 3. Okay, so I factored 4 terms. I had 4 terms to begin with. I now have 2 terms. I forget, this one's raspberry, I believe. Yeah, raspberry. Boysenberry is more of a purplish hue. This is raspberry flavor. I have 2 terms. Now, I do GCF again. Do those 2 terms have any factor in common? And this is where you have to train your eye. The answer is yes. They have a binomial factor in common. See that? They both have a 4x minus 3 in common. Yes, yes? All right, so here's what we're going to do. We'll choose Mandarin. Oops, that's for my highlighter. Do I have Mandarin here? There it is. I'm going to pull out a 4x minus 3. parentheses. What am I left with in the first term when I pull the 4x minus 3 out? What's the part that's not highlighted? X squared. Plus, in the second term, when I pull the 4x minus 3 out, what am I left with? What's the part that's not highlighted? 2. Okay, so that factors that. Now, I do look at this middle part here. It's not a linear factor. It's an x squared factor. Sometimes x squared factors can go further. But guess what? This one, as I mentioned up here, is a quadratic prime because it is a plus sign. If you ever see x squared plus something, it doesn't factor. X squared minus something does. But if you see x squared plus something, it's a prime factor. So this one's prime because it's of the form mx plus b. It's linear. And this one is also prime because it's ax squared plus b. The plus sign is what's important. This is quadratic. That's the answer. We factored it out. Yeah, watch this. I know this is where you have to train your eye. Let's imagine that this 4x plus 3 right here is just a big ol' x. Would you be okay with that? It's a big ol' x. If I distribute this back in, I'm going to get big ol' x times x squared. We'll make this a different kind of x. Big ol' x, okay? It's big X, like Texas X. And then plus 2 times big ol' x. Would you agree if I distribute that x through? Okay, now let's substitute it back in. What is big ol' x really? Big ol' x is really 4x minus 3. So that's really 4x minus 3 times x squared, which I'll put on the left, plus 2 times big ol' x, which is 4x minus 3. Think of that as a single unit. We're factoring out a two-term factor, but we're treating it like a single unit. Okay? All right, or if you think about it backwards, think about this as big ol' x and big ol' x, and you're factoring out big ol' x. Big ol' x. All right. Comments or questions on that one? Okay, we're working up to factoring trinomials like we did in the warm-up. Now we're going to factor by doing a difference of squares or a perfect square trinomial. This one is important. This is of the form ax squared minus b. This one is factorable. This is a difference of squares. A difference of squares. Here's what a difference of two squares factors into. It factors into a double bubble. Okay? These are going to be called conjugates. One of them is plus, one of them is minus. That's what makes them conjugates. You got to remember this. A difference of squares will factor into two conjugates. Now, what goes in front of the plus and minus signs? Well, you remember when we completed the square? I said it's just the square root of the first. What's the square root of x squared? X. And what goes into the second? Well, what's the square root of 64? 8. That's how you factor it. X plus 8, x minus 8. Now, why does that work? Let's check it. Let's check it. We could FOIL this one, can't we? Let's FOIL it and see why that works. The first is x times x, that's x squared. The outer is x times negative 8, that's minus 8x. The inner is positive 8 times x, that's positive 8x. And the last is negative 8 times negative 8, which is negative 64. What happens on the inside when you combine your two outer and inners? They cancel. They cancel, forming a 0, and you're left with x squared minus 64. Okay? And that's why we call those conjugates. One of them is plus and one of them is minus, and that's how you get them to cancel each other out. All right, this is the last one for the day. X squared minus 6x plus 9. You got this one. We've already done this one. You remember when you completed the square on the test? This is a perfect square trinomial. A perfect square trinomial. It's what we did when we completed the square. Okay, it's going to factor into a bubble squared. Bubble squared. Okay, and how do we factor it? You already know this. It's the square root of the first, it's the square root of the last, and it's the middle sign. That's it. It's x minus 3 squared. Okay? You already know how to do that. If you want to check it, here's the last thing we'll do. We'll check it by writing it side by side. X minus 3 squared is the same as x minus 3 times x minus 3. If we FOILed it, we get x times x, that's x squared. The outer is negative 3x, and the inner is also negative 3x. So instead of being opposite signs and canceling, they're the same sign, and they end up doubling. What's minus 3x minus 3x? Minus 6x plus 9, and we got the answer. Okay. Tomorrow we'll pick up with example 7, which is kind of where we started today. Or example 6, sorry. Factoring trinomials, which is unfoiling. Okay? So we did all kinds of stuff today leading up to unfoiling. But we started the day with unfoiling, so tomorrow should be pretty easy. Okay? And then we'll start chapter 5. Any comments or questions on today's lesson? I got to go to the Dino Club meeting during advisory, so y'all will be on your own.